Hello everyone, welcome back to my channel. Let's solve the 2025 Kangaroo Math Competition problems. These problems are for grades 11 and 12. Let's start. Question number 1. The number of the year 2025 is a perfect square because 2025 is equal to 45 squared. How many years will pass until the next year whose number is a perfect square? The next perfect square to 45 squared is 46 squared. And 46 squared is equal to 2116, and the difference between 2116 and 2025 is 91. So the answer is 91 years, and that is option B. Question number 2. Mike obtains a number x by dividing the number square root of 11 by 3. Where is the number x located on the number line? You can just simply compute the square root of 11 and then divide it by 3 to get the answer. But I'll show you another solution. Take note that 11 is between the perfect squares 9 and 16. So 11 is greater than 9 but less than 16. Now if we get the square root of each number, we get the square root of 11 greater than 3 but less than 4. Now if we divide each number by 3, we have square root of 11 over 3 greater than 1 but less than 4/3. Take note that 4/3 is the same as 1 and 1/3. Now we see that square root of 11 over 3 is between 1 and 2. So the answer is option B. Question number 3. Vasily has 20 balls. Each ball is either yellow, green, blue, or black. Of the balls, exactly 17 are not green, exactly 15 are not black, and exactly 12 are not yellow. How many of his balls are blue? Let us start by representing the number of balls of each color. Let's say we have A for the number of yellow balls, B for green balls, C for blue balls, and D for black balls. Since the total number of balls is 20, we have the equation A plus B plus C plus D equals 20. Now, it also says here that exactly 17 are not green. This means that the total number of yellow, blue, and black balls is 17. So we have the equation A plus C plus D equals 17. Similarly, we have exactly 15 are not black, meaning the total number of yellow, green, and blue balls is 15. So we have the equation A plus B plus C equals 15. And finally, we have the condition exactly 12 are not yellow, meaning the total number of green, blue, and black balls is 12. So we have the equation B plus C plus D equals 12. Now, let's add these three equations. If we do that, we obtain 2 copies of A, 2 copies of B, 3 copies of C, and 2 copies of D. So we have 2A plus 2B plus 2C, plus 3C plus 2D, which is equal to 44. Now take note that we want the number of blue balls, so we are finding the value of C. Now take note that there are 3 copies of C, and if I split 3C into C plus 2C and then group the remaining terms 2A, 2B, 2C, and 2D and factor out 2, we will have C plus 2 times A plus B plus C plus D equals 44. And take note that A plus B plus C plus D is equal to 20. So we can just replace this part by 20. So we have C plus 2 times 20 equals 44, which means that C plus 40 equals 44, and finally C equals 4. So there are 4 blue balls. So that's letter D. Question number 4. Which interval contains the value of the product 77 times 777? Alright, you can just compute directly the product of 77 and 777. And if you do that, the answer is 59,829. And obviously, the answer must be option D. Now, what's the alternative solution without multiplying the two numbers? Notice that 77 times 777 is greater than 77, 777, and 7,777. Alright? So, already, A, B, and C are not the correct answers. Right? Now, you can just examine both D and E. Which one contains the number 59,829? Okay? So, the answer here is option D. Question number 5. Which of the following expressions has the same value as the square root of 16 raised to 16? Let's get first the square root of 16 raised to 16 and then simplify the base and the exponent. Whatever base raised to a certain exponent is um, whatever base raised to a certain exponent we will have later on. Okay, so we'll have here square root of 16 raised to 16. Take note that this expression is the same as 16 raised to 16 raised to 1 half, because the index here is 2. If we change this into exponential form, this should be 16 raised to 16 raised to 1 half. And by law of exponent, we will have 16 raised to 16 over 2, which is the same as 16 raised to 8. However, we don't have a base of 16 from options A to D, and obviously E is incorrect, right? Let's change the base of this by having 4 squared raised to 8. And again, by law of exponent, we will just multiply 8 and 2, so we will have 4 raised to 16. Okay, so the answer here is option C. Next item, number 6. The pictures shown are the first 3 pictures in a sequence. How many dots does the fifth picture in the sequence consist of? Notice first that each figure is symmetric, right? So, for example, in figure 1, you have in the first column you have 1 dot, in the next column you have 3 dots, right? But if you look at this part of the figure, in the leftmost column you have 1 dot, in the next column you have 3 dots, right? So it's symmetric about the center. So we can just count the number of dots in the left side and just multiply it by 2 to get the total number of dots. Okay, so for figure 1, notice that the number of dots is 2 times 1 plus 3. For the next figure, notice that we have 2 times 1 plus 3 plus 5. Take note, I'm just looking at this part here. Okay, so at this part I enclosed with a triangle is 1 plus 3 plus 5, but this one is exactly the same as the left side of the figure, so I multiplied it by 2, right? Now, in the next figure, if you look at this part, that is just 1 plus 3 plus 5 plus 7. Since there are two parts, we'll just multiply this one by 2, right? Now, so for the fifth picture, we expect the following expression. 2 times 1 plus 3 plus 5 plus 7 plus 9 plus 11, right? So this is the total number of dots in the fifth picture. Notice that this expression is just an arithmetic series. So if you're familiar with the formula for an arithmetic series, you can just use that formula. However, you can just manually add these numbers since there are only 6 numbers, right? Okay, so if we add all of these numbers inside the parentheses, you must have 2 times, using the formula for arithmetic series, you have 6 over 2 times 1 plus 11. That's equal to 6 times 12, which is equal to 72. Okay, so the answer is option A. Problem number 7. A student throws 5 stones in turn, hitting a window at points A, B, C, D, and E. Whenever a stone hits the window, it creates cracks starting from that point. These cracks end either at the edge of the window or at an existing crack. In which order did he throw the stones? Let us name the stones A, B, C, D, and E corresponding to the points on the window. Now, the stone that was thrown first must have created cracks that went all the way to the edge of the window. And obviously, the stone that created such cracks that went all the way to the edge of the window is stone D. So, we immediately eliminate options B, C, and D. Now, the next stone that was thrown must have created a crack that intercepts one of the cracks created by stone D. And obviously, it is stone A. So, the next stone that was thrown was stone A. Okay? And by the same reasoning, the third stone that was thrown must have created a crack that intercepts one of the cracks created by stone A. And obviously, it is stone C. And then it must be followed by stone B by the same reasoning, and lastly by stone E. So the answer must be option A. Problem number 8. Sylvia's favorite chocolate bars are sold in packets. There used to be 5 bars in each packet. Now there are only 4 in each packet, but the packets still cost the same. By how many percent has each bar become more expensive? Let us suppose that the price of one packet of 5 bars is P. So the price per bar is P over 5. Now, if there are 4 bars in a packet and the price per packet is still P, then the price per bar is P over 4. So the new price per bar is P over 4. Now, if we subtract uh, P over 5 from P over 4, we get the difference in price, right? But we want the percent as answer. So we subtract P over 5 from P over 4 and then divide by the original price, which is P over 5. Alright? Now, to get rid of the denominators, I'll just multiply the top and the bottom by 20. So I'm going to multiply this one by 20 and this one by 20 as well. Alright? So, we have 5P minus 4P over 4P. So we have P over 4P which is equal to 1/4 or 25%. So the answer is letter C. Problem number 9. ABCD is a rectangle. The area of the quadrilateral ABPD is 4 cm squared and DP is equal to 1/3 CD. What is the area of the rectangle ABCD? Let us make first the diagonal DB to divide the rectangle into two congruent triangles. So let's connect points D and B. Alright. So diagonal DB divides the rectangle into two congruent triangles ABD and CDB. So the area of triangle ABD must be equal to the area of triangle CDB. So we are using this notation for the areas. Alright. Now suppose that the area of triangle ABD is A. So the area of triangle CDB must also be A. So each of this is equal to A. Now, notice also that the sum of the areas of triangle ABD, so area of triangle ABD, and the area of triangle DBP is equal to the area of quadrilateral ABPD. Alright. Now, since a DP is 1/3 of CD, the area of triangle DBP must also be 1/3 of the area of CDB. But the area of CDB is A, right? So area of DBP must be equal to 1/3 A. Alright? So now, this equation is the same as A. Take note, A is the area of triangle ABD. So that's the same as A plus 1/3 A, which is equal to 4, because the area of quadrilateral ABPD is 4. Alright? So let's simplify this equation. So if we multiply both sides of this equation by 3, we get 3A plus A equals 12. We have 4A equals 12, and so A is equal to 3. Now, we're looking for the area of the rectangle. The area of the rectangle is just 2A, right? So 2A, so that's equal to 2 times 3, which is equal to 6. So that's option C, 6 cm squared. Problem number 10. In the xy plane, some points in the range x greater than or equal to 0 but less than or equal to 1 and y greater than or equal to 0 but less than or equal to 1 are colored black. A point xy is colored black if and only if the first decimal digit of both x and y after the decimal point is odd. What does the result look like? Okay, let's determine the range of values for the x and y coordinates. For the x coordinates, the x coordinates must belong to one of the following intervals: x greater than or equal to 0.1 but less than 0.2, x greater than or equal to 0.3 but less than 0.4, all the way to x greater than or equal to 0.9 but less than 1. Also, for the y coordinates must belong to one of the following intervals: y greater than or equal to 0.1 but less than 0.2, y greater than or equal to zero point 0.3 but less than zero point 0.4, and so on up to y greater than or equal to zero point 0.9 but less than 1. Now notice that if you get any value of x on one of these intervals, any value of y on one of these intervals, the digit that follows the decimal point is always odd, right? So these points that we create using these intervals satisfy the given conditions. Now let's take a specific example. Let's take a number between zero point 0.1 and zero point 0.2. Let's say 0.15. That's our x coordinate. Now for the y coordinate, let's take a number between zero point 0.3 and zero point 0.4. Let's say that's 0.36. Okay. Let's take another one. Let's have the x coordinate 0.94 and the y coordinate 0.35. Alright. Now, any combination of x and y coordinates from these intervals satisfy the given condition. Now, let's plot the first point that we have chosen. So, 0.15, so this must belong to this interval. 0.36 must belong to this interval. So, this point must be in this region. Okay? It must be in that region. For the second one, 0.94 belongs to this interval, right? And then 0.35 also belongs uh, to this interval. Okay, so this point is found here in this region. Okay, so you can try some other points and you'll find out that if you continue the process, okay, you will come up with the figure in option E. So our answer here is option E. Problem number 11. Robert wants to choose 4 points in such a way that the distances between any two of them are different. Which one of the points A, B, C, D, or E must he remove? Let us connect first any 2 points and compare distances. So we have the segment AE, AB, BC, CD, ED, and then BD, BE. We also have AD, AC. What else? We also have EC. Right? Now, let's compare distances. Notice that AB is equal to CD, which we don't want to happen because we want distances to be different. Also, we have BD equals ED, and then we also have AD equal to EC. So it appears that we produced a lot of equal segments if we include point D. Now let's eliminate point D and all the segments coming from point D. Let's see what happens. So if we eliminate point D, we eliminate this segment, this one, this one, this one. Now let's see if there are equal distances. Okay, so it seems that all the distances are different already. So the point that must be eliminated or removed must be point D. So the answer is option D. Problem number 12. Among 10 different given positive integers, exactly 5 are divisible by 5, and exactly 7 are divisible by 7. Let m be the largest of these numbers. What is the smallest possible value of m? To minimize the value of m, we must make sure that the numbers are small as possible. Now, 2 of the 7 positive integers divisible by 7 must also be divisible by 5, since there are 5 positive integers divisible by 5 and the total number of integers in the list is 10. Now, the first 6 positive integers divisible by 7 are 7, 14, 21, 28, 35, and 42. And take note that 35 is divisible by 5. Now, we need one more number that's divisible by both 7 and 5, since we need 7 integers divisible by 7. Now, we need this to be small as possible because we are minimizing m, and we must include 70. Okay, so there are already 7 positive integers divisible by 7, and 2 of them are divisible by 5. Since there are 10 positive integers in the list and 5 of them must be divisible by 5 as well, then we must include 5, 10, and 15. Alright, so 5, 10, and 15. Now we have the complete list of the 10 positive integers. So the value of m here is 70. And so the answer is not among the options from A to D. So the answer here is option E. Problem number 13. In the diagram, we see a quarter circle SP with center O and radius R, as well as a triangle ORP. The two gray regions have the same area. How long is the segment OR? Since we have a quarter circle, this angle must be 90 degrees. And so we also have a right triangle. Now, we can represent each of the gray regions by A since they have the same area. Let us also represent the unshaded region by B. Now, the area of the quarter circle is given by 1/4 pi r squared, which is also equal to A plus B. Meanwhile, the area of the triangle is given by 1/2 times the base, which is R, times the height, which is OR. This is also equal to A plus B. Okay. Since the two areas are equal to A plus B, they must be equal to one another. So we have the equation 1/4 pi r squared equals 1/2 R times OR. Now, if you multiply both sides by 2 and then divide also both sides by R, we must get OR equals 2 over 4 times pi r squared over R. So if we cancel common factors, we get OR equals 1/2 pi r. So the answer is option A. Problem number 14. A student draws the graphs of two linear functions in a coordinate system as shown. What is certain about the expression AB plus CD minus the quantity AC plus BD? Let us determine the signs of A, B, C, and D. Now, if you look at the line y equals AX plus B, the graph rises from left to right. So its slope A must be greater than 0. Okay, so we have A greater than 0. Also, the y-intercept of y equals AX plus B is above the x-axis, right? So B must also be greater than 0. Now, For the line y equals cx plus d, its graph descends from left to right, meaning the slope of y equals cx plus d must be less than 0. The slope of this line is c, so c is less than 0. Also, the y-intercept of y equals cx plus d is below the x-axis, meaning d is also less than 0. Now, let us determine the signs of AB, CD, AC, and BD. Since A is greater than 0 and B is also greater than 0, then we can say that AB is greater than 0. Since C and D are both less than 0, then CD must be greater than 0. Now, how about AC? Since A is greater than 0 and C is less than 0, AC must be less than 0. BD, since B is greater than 0 and D is less than 0, BD must be less than 0. Now, since AB is greater than 0 and CD is also greater than 0, AB plus CD must be greater than 0. Since AC is less than 0 and BD is less than 0, AC plus BD must be less than 0 as well. Now, if you multiply negative 1 to this inequality, you get the negative of AC plus BD. So you have negative of AC plus BD greater than 0. Now finally, combining the two inequalities AB plus CD greater than 0 and negative of AC plus BD greater than 0, we get that AB plus CD minus the quantity AC plus BD must be greater than 0. Okay? Now let us look at the options. So it says in letter C that it is positive, so this is our final answer because the expression that we got is greater than 0. Problem number 15. When Grandma started knitting wool socks, she had a ball of wool with a diameter of 30 cm. After she has finished knitting 70 socks, the remaining ball of wool has a diameter of 15 cm. How many more socks can Grandma knit? We will determine first the volume of wool used to knit 70 socks by subtracting the volume of the remaining ball of wool from the original volume of wool. So we have 4/3 pi 15 cubed the volume of the original ball of wool minus 4/3 pi 15 over 2 cubed, the volume of the remaining wool. So 4/3 pi times 15 over 2 cubed. Now I'm not going to simplify everything since I'm expecting that common factors will cancel later on. So this one is equal to 4/3 pi 15 cubed minus 4 over 24 4 over 24 pi times 15 cubed. So I'm going to get the LCD. So we have 32 over 24 pi times 15 cubed minus 4 over 24 pi times 15 cubed. So we're going to get 7 over 6 pi times 15 cubed. Alright, now if we divide 7 over 6 pi times 15 cubed by 70, we get the volume or amount of wool used per sock. Okay, So if we do that, we have 7 over 6 pi 15 cube over 70. That should give us 225 pi over 4. So this is cm cube per sock. Now if we divide the volume of the remaining wool by this number, we get the number of additional socks that can be made. So we have 4/3 pi 4/3 pi times 15 over 2 cubed. The volume, this is the volume of the remaining amount of wool. If we divide this one by 225 pi over 4, we get 4/3 pi times 15 over 2 cubed times 4 over 225 pi. Now if we cancel common factors, we must get 10. Alright, so the answer is option E.